Hello everyone. Let's continue with the normal form. So here a relation is given, relation R, that is A B C D E F, A B C D E F, and functional dependencies are given as A goes to B C D E F, B C D E F, and BC goes to A D E F, A D E F, and B goes to F, B goes to F, and D goes to E, D goes to A. So these are the functional dependencies given, and try to find out the highest normal form. What is the highest normal form? Okay, candidate keys are given as that is A and PC. These are two candidate keys. Now let's start with BCNF. Here it is BCNF or not. So A is the super key, it means it is BCNF. BC is a super key, it is BCNF. B is not a super key, cannot be BCNF, and D is not a super key, it cannot be BCNF. What about the third normal form? So in 3NF, it will satisfy because of super key, it will satisfy because of, okay, it is 1NF, okay. So what about this one? Here B goes to F. B goes to F means either it should be super key or this should be the prime attribute. So F is not a prime attribute and B is not a super key. So it cannot be the third normal form. Just a minute. जी. Okay, so this one is not in 3 enough. What about the next one? Next is D goes to E. So D goes to E, that is, this is a super key or not? So D is not a super key. D is not a super key. And what about E? E is a prime attribute, not a prime attribute. So it cannot be the third normal form. So it is not in third normal form. What about next one? Next one is second normal form, second NF. So second NF means that here it is in second normal form, not a problem. And here super key, so not a problem. It is also second normal form. What about this one? B goes to F. So B goes to F is what? It is the proper subset of candidate key. B is the proper subset of candidate key that determine F is the non-prime attribute, right? So B is the proper subset of candidate key and F is the non-prime attribute. It means in this case there is a partial dependency, right? So here it is partial dependency. Due to the partial dependency, it is not in second normal form, right? So here it is failing to be in second normal form. So it is not in second normal form. What about this one? D goes to E. D is the proper subset of candidate key or not? This is not the proper subset of candidate key. So there is no chance to be partial dependency, right? So there is no chance of partial dependency. So this case is valid, right? So due to this one, it is not in second normal form. Now, what about the first normal form? So, one and a. So, in case of one and a, that this will satisfy, not a problem, because in one and a we are looking for the multi-valued attributes. So here there is no multi-valued attribute, or we can say multi-valued functional dependency exists. So here it will satisfy on in all the cases, right? So here highest normal form is the first normal form. Is it clear to all? Okay, fine. Now, next thing, now we are looking for the decomposition into highest normal form. So, can we decompose this one and can we go to the second normal form? So, here, due to this one, it is not in second normal form, right? So, due to B goes to F, it is not the second normal form. So, क्या किया जा सकता है? So, we can break the relation into two sub relations. So relation R that can be break into two sub-relations. One is R1, another one is R2. So R1 having the attributes A, B, C, D and E. A, B, C, D and E, and R2 having the attribute that is B and F. R2 having attribute B and F. Now we'll check that decomposition is lossless joint decomposition or not, dependency is preserving or not, right? So tell me it is lossless joint decomposition or it is lossy joint decomposition. Okay, so here if we observe R1 intersection R2, that is equal to common attribute, that is F, that is B. B is the common attribute, right? So B should be the super key of either this one और this one. तो इनमें से किसी एक की क्या होनी चाहिए, सुपर की होनी चाहिए. Now B is the super key of what? Here we can say functional dependency will be B goes to F, and in such a case B will be the super key, right? So we can say here B will be the super key of relation R2. It means join will be lossless join decomposition. Lossless join decomposition. Yes, is it clear to all? Okay, fine. What about the dependency is preserving or not? Dependency is preserving or not? So here dependency is preserving. Let's see. Here, if we find out the dependency for this subrelation, dependency will be A goes to B, C, D, E, B, C, D, E, B, C, D, E. Another one is B, C goes to A, D, E, and D goes to E. Right? These are the functional dependencies for a relation F1, sorry, it is R1, and this is the functional dependency for relation R2. And if let me say this one is F1 and this one is F2, then F1 union F2, that should be equal to F, and F is these functional dependencies, right? So it should be equal to F. So now we can check that these are deriving here, these are implying here or not after performing the union operation. So here A goes to B, C, D, E, F, right? So directly we cannot find, but if we take the closure of A, then we'll get A, B, C, D, E, B, C, D, E, and B goes to F. B goes to F, so we can derive F also. So here A is derived, A can derive A, B, C, D, E, and F. So this functional dependency is implied. What about this one? BC goes to A, D, E, F. So BC goes to A, D, E, F. It is implying or not? Let's see. So we'll take the closure of BC. BC closure is BC A D E BC A D E, and B can derive F also. So here F also. BC can derive. So this is what trivial case, and after that it can derive ADEF, right? So this is also implying B goes to F directly since, and D goes to E, it is a directly given, right? It means F1 union F2, that is equal to F. So we can say dependency is preserving. Dependency is preserving. So till this part, is it clear to all? Okay, fine. Now let's see, after decomposition it is in second normal form or not, right? After decomposition it is in second normal form or not. So functional dependencies are these: A goes to BCD, BCD, E, A goes to BCDE, and next is BC goes to ADE, BC goes to ADE, and D goes to E, D goes to E, and one is B goes to F, B goes to F, right? Now, what about the candidate key? For this sub-relation, candidate key is B, means for R2, candidate key is B, and for R1, relation R1, candidate key is A and BC, A and BC. So, till this part it is R1 and this one is R2, ठीक है? तो नॉर्मल फॉर्म चेक करते हैं. व्हाट अबाउट द 2NF? Here it is 2NF or not. So A is the super key, not a problem. BC is a super key, not a problem. It is in second normal form. What about next? D goes to E. D goes to E. So here there is a partial dependency or not. So D is the proper subset or not? Not a proper subset. तो नॉट चांस ऑफ पार्शियल डिपेंडेंसी। अगर इसका प्रॉपर सबसेट नहीं है तो फिर क्या होगा, चांस नहीं बनेगा पार्शियल डिपेंडेंसी के लिए, राइट। so here it is not a partial dependency, means this case is valid. And what about b goes to f? So we know that b is the super key, so this case is valid. So this is in second normal form. After decomposition, this is what in second normal form. Before decomposition it was in first normal form, but after decomposition it is in second normal form. You can check for the third normal form. It is in third normal form or not? Yes, tell me, it is in third normal form or not? Check that it is in third normal form or not. Okay, it is not in third normal form. So if we observe this one here, it is the super key, it is third normal form. Here also super key, third normal form. What about this one? D is a super key? No. E is a prime attribute? No. So due to this one, it is not the third normal form, right? But what about this one? B goes to F. So F is a super key or not? F is not a super key. Sorry, B is a super key. Yes, B is a super key. So this case is valid. But due to this one, it is not in third normal form. Now we can do the further decomposition. And after decomposition, we can go to the highest normal form, that is third normal form, right? So what will be the further decomposition? Let's see. Now we can divide this relation R into three sub-relations. So first one is R1. R1 is A, B, C, D, A, B, C, D, and R2 is D and E, because of this one there is a problem, so it is D, E, and R3 is R3 is B goes to F, means BF. This is what R3, right? Now we can check that the dependency is preserving or not, lossless joint decomposition or not, right? So here tell me there is a lossless joint decomposition or not. Or firstly check that the dependency is preserving or not. Yes, tell me dependency is preserving or not. And second thing, lossless joint decomposition or not. let's see. So here functional dependency for this sub relation, let me say this is f1, so it will be a goes to bcd, a goes to bcd, bc goes to ad, bc goes to ad, and for this one functional dependency will be d goes to e, and for this one functional dependency, that is f3, that will be b goes to f, b goes to f, right? These are the functional dependencies. Now what will happen? uh, Now we'll check that f1 union f2 union f3, that is equivalent to f or not. This is what equivalent to f or not. So if we observe this one, it is implying or not? This functional dependency is implying here or not? So A, B, C, D, E, F. So let's take the closure of A. A closure is A, and A goes to BCD, BCD, and BC goes to AD, and D goes to E, and B goes to F also. So here it is A, B, C, D, E, F. So this one is satisfying. What about BC closure? So if we take the BC closure is AD, BC itself, after that ADE, BC, BCAD, and D goes to E, right? And E goes to B goes to F also. B goes to F. So it can derive ADEF. ADEF. It means this one also satisfying. What about B goes to F? B goes to F is directly given, and D goes to E, that is directly given, right? It means dependency is preserving, right? So dependency is preserving. Is it clear to all? Okay, fine. Now let's see the lossless joint decomposition or not. So let's check for R1 union R1 intersection R2. So what is the common attribute between these two? This one and this one. So D is the common attribute. Now D is the attribute and D is the super key for any subrelation. Yes, D is the super key for this subrelation because it is D goes to E, D is the candidate key. So here this will be the super key for subrelation R2. तो D R2 के लिए क्या है सुपर की है. इसका मतलब क्या हो गया R1 और R2 को क्या किया जा सकता है कंबाइन किया जा सकता है राइट. So we can combine R1 R2. So here it is R1 2. Now R12 means it is A, B, C, D, इसके एट्रीब्यूट प्लस इसके एट्रीब्यूट, तो ई, ये अब ये आ गया। इसका इंटरसेक्शन किया जा सकता है किसके साथ, R3 के साथ। नाउ टेक द इंटरसेक्शन विद R3। R3 में B और F है, तो कॉमन एट्रीब्यूट क्या रहेगा, B, B is the common attribute, right? After intersection, common attribute is B. Now check that B is the super key of anyone. So B is the super key of any of these. Yes, B will be the super key for R3. R3 because it is B goes to F, तो यहाँ पे B क्या बनेगी, सुपर की। B goes to F है ना, तो B का मतलब सुपर की बनेगी, तो B is the super key for this one. So finally we can say it is a lossless join decomposition. Lossless join decomposition. So two things are there, that dependency is preserving and lossless when decomposition. So we can say the decomposition that can be valid decomposition only if dependency is preserving and lossless when decomposition. Is it clear to all? Now we can check for the third normal form. It is in third normal form or not, राइट? तो क्या करेंगे, इसमें चेक कर लेंगे ये थर्ड नॉर्मल फॉर्म में है या नहीं, ये सारी एफडी होंगी, राइट? एंड फाइनली इफ वी ऑब्जर्व दिस वन, इट इज डेफिनेटली इन थर्ड नॉर्मल फॉर्म, राइट? तो ये थर्ड एनएफ में होगा और ये बीसीएनएफ में भी रहेगा, राइट? थर्ड में भी होगा और ये बीसीएनएफ में भी होगा। चेक कर लेंगे ना, चेक करना अपने को आता है।